Now we are going to the second one. Let P be an order prime. Then sigma over R ranges from 1 to P minus 1 R square into R by P equals P into sigma over R ranges from 1 to P minus 1 R into R by P. R into R by P if P congruence to 3 mod of 1. If P congruence to 3 mod of 1. How to solve this one? Solution is, again we can start from here. Sigma R ranges from 1 to P minus 1 R square into R by P. Also we know that R and P minus R runs through the same numbers 1, 2, 3 etc. up to P minus 1. So you can replace R by that P minus R. So it is R ranges from 1 to P minus 1 P minus R whole square into, again R by P. R by P means P minus R into by P. Okay. But again we know that what is R by P? R by P equals minus 1 to the power P minus 1 by 2 P minus R by 2. What is P here? P is congruence to 3 mod of 4. P congruence to 3 mod of 4 means, what is P minus 1 by 2? P congruence to 3 mod of 4. So what is P minus 1? P minus 1 congruence to P minus 1. P minus 1 congruence to 2 mod of 4. So what is P minus 1 by 2? P minus 1 by 2 congruence to 1 mod of 4. 1 mod of 2. So when P congruence to 3 mod of 4, P minus 1 by 2 is always odd. Why? Because consider this 7 congruence to, we know that 7 congruence to 3 mod of 4. What is 7 minus 3? Sorry, 7 congruence to 3 mod of 4. But what is 7 minus 1 by 2? 6 minus 1 by 2, 3. That is odd. So when P congruence to 3 mod of 4, we know that this gives P minus 1 by 2 is odd. But we know that R by P equals minus 1 to the power P minus 1 by 2 P minus R by P. Since this is odd, this becomes minus 1. So P minus R by P is nothing but a minus R by P. Okay. So this can be, you can replace this by minus R by P. Agreed. Therefore this formula becomes sigma R ranges from 1 to P minus 1 P minus R whole square into minus R by P. So it is R by P. Take this minus sign outside. Okay. So that equals minus of sigma R ranges from 1 to P minus 1. It is P square into R by P. On expanding this one, minus 2P into sigma R ranges from 1 to P minus 1 R into R by P plus R sigma R ranges from 1 to P minus 1 R square into R by P. R square into R by P. So this is, there is sigma R square into R by P minus sigma R square into R by P. So bring to the left side. So it is 2 into sigma R ranges from 1 to P minus 1 R square into R by P is given. We know that this is nothing but minus sigma R ranges from 1 to P minus 1. So since P square is strictly independent of this R, so it is R by P. Okay. Minus, it is same as 2P into minus of minus plus 2P into sigma over R ranges from 1 to P minus 1 R into R by P. Bring this third term to the left side. We know that sigma R ranges from 1 to P minus 1 R by P is always 0. Not out. So this term always goes to 0. So what remains here? That means sigma R ranges from 1 to P minus 1 R square into R by P equals 2 into 2 and 2 are cancelling each other. So it is P into sigma over R ranges from 1 to P minus 1 R into R by P. So this is the required result. Okay. Now we are going to our third result. The same argument, that is if P congruence to 1 mod of 4, again we goes to here. If P congruence to 1 mod of 4, then sigma r ranges from 1 to P minus 1 r cube into r by P equals, the value is r cube into r by P is 3 by 2 into sigma r ranges from 1 to P minus 1 r square into r by P. This is our next problem. P be an order prime and sigma r ranges from 1 to P minus 1 r cube into r by P is nothing but 3 by 2 into sigma r ranges from 1 to P minus 1 r square r by P if P congruence to 1 mod of 4. Agree? So we know that when P congruence to 1 mod of 4, what is P minus 1 by 2? P minus 1 by 2 is C1. Since P minus 1 by 2 is C1, we know that R by P is nothing but P minus R by P. Why? Because minus 1 to the power P minus 1 by 2 is 1 itself. So this can be rewritten as this again, sigma R ranges from 1 to P minus 1 R cube into R by P is nothing but, what is R cube? It is sigma R ranges from 1 to P minus 1 R cube. It is P minus R whole cube into again R by P. It is P minus R by P. P minus R by P. So that equals sigma R ranges from 1 to P minus 1. It is P cube into P minus R by P. From here, what is P minus R by P? It is R by P itself. So it is again one more P minus R whole cube into R by P. That equals sigma R ranges from 1 to P minus 1. You can expand this one. So it is P cube into R by P minus sigma R ranges from 1 to P minus 1 3 P square R into R by P plus 3 P into sigma R ranges from 1 to P minus 1 R square into R by P minus sigma R ranges from 1 to P minus 1 R cube into R by P. So you can bring the last negative term to left side. It will become 2 into sigma or R ranges from 1 to P minus 1 R cube into R by P is nothing but, we know that P cube goes outside of the summation. So we know that sigma R by P goes to 0. It is minus 3P square R into R by P plus 3P into sigma R ranges from 1 to P minus 1 R square R by P. So the second term is minus 3P square into sigma R ranges from 1 to P minus 1 R into R by P plus what remains here? It is 3P into sigma R square, sigma where R ranges from 1 to P minus 1 R square into R by P. When P congruence to 1 mod of 4, we prove this result. Sigma R ranges from 1 to P minus 1 R into R by P goes to 0. Why? Because our first problem. So this term again goes to 0. So this left side becomes 3P into sigma R ranges from 1 to P minus 1 R square into R by P. So 2 of this one is that one. So it is nothing but 3 by 2 into, yes, there is a P, 3 by 2P into sigma R square into R by P itself. Agree? So this is what we require here. Similarly, you can show that when P congruence to 3 mod of 4, sigma R ranges from 1 to P minus 1 R to the power 4 of R by P. When P congruence to 3 mod of 4, use the idea that P minus 1 by 2 is odd. So R by P is minus 1 to the power P minus 1 by 2 P minus R by P. So P minus R by P is there minus R by P. Using that idea, then you can prove that result also. Agree? So here we use the ideas when always use the two important ideas are here. That is P minus R and R runs through the same numbers 1, 2, 3 etc. to P minus 1. Moreover, result is r by p equals minus 1 to the power p minus 1 by 2 into p minus r by p. So these are the two important results. Okay. So these are our problems. Now we are going to another problem. That is, if p be an odd prime, this is another one. If p be an odd prime, then sigma r ranges from 1 to p minus 1 r by p, sorry r, simply r, equals p into p minus 1 by 4 if p congruents to 1 mod of 4. Sigma r ranges from 1 to p minus 1 r equals p into p minus 1 by 4 if p congruents to 1 mod 4. How? Again we know that sigma r ranges from 1 to p minus 1 r is nothing but sigma r ranges from 1 to p minus 1 p minus 1. Okay. Okay. So that is nothing but sigma r ranges from 1 to p minus 1. You know that it is only sigma r. So it is p minus sigma r ranges from 1 to p minus 1 r. Agree? Okay. So this is nothing but p into sigma r ranges from p into sigma r ranges from 1 to p minus 1 1 minus sigma r ranges from 1 to p minus 1 r. Bring this one to here. So it is 2 into sigma r ranges from 1 to p minus 1 r is p into p minus 1. Why? Because sigma r ranges from 1 to p minus 1 of 1 is nothing but p minus 1. But here, since there are p minus 1 by 2 quadratic residues, then sigma r ranges from 1 to p minus 1 r equals p into p minus 1 by 2. Since there are p minus 1 by 2 quadratic residues, so it is equals p into p minus 1 by 4 itself. Okay, so this is our. So these are the important problems regarding the reciprocity laws and the Legendre's symbol. Okay, thank you.